This recording is intended as an example for future engineering and computer science students. And so the project that I've been working on for my service learning project is a chess program. And basically the program that I've been working on is supposed to be able to play a game of chess. You're supposed to be able to input a chess move, and then the computer will generate a response, and it'll be able to play a chess game and just go back and forth. And so the basic layout of my chess program has been very minimal so far. In the future, I'm going to expand and make it a little more complex. But for now, the main structure of it is going to be to input a chess move using algebraic notation. And basically the way the algebraic notation works is it identifies a certain move by the name of the piece, which is abbreviated using P for pawn, and N for knight, or B for bishop, etc. And then the place where the piece is on, the square the piece is on, and then the square that the piece is moving to. For example, the first move could be Pe2-E4, which is basically the first move for a pawn, where the pawn and then where square is moving from and the square is moving to. And so you both input, the user will input that move, and then the computer will generate that as a response. Later on in my program, I'm probably going to be adding a graphical interface where the player can actually play the game using an actual board. But for right now, my chess program is just going to be using algebraic notation. And so the basic way that the chess program is going to be able to calculate moves, I'm using a process called bitboards. And there are many different ways that a chess program can be made possibly. And there are a variety of ways that you can look up on the internet. But and basically the way bitboards work is that it uses a basic data structure which is basically just a byte. And specifically it uses a 64-bit byte. And a nice coincidence is that there are also 64 squares on a chessboard. And so what you're able to do is you're able to represent each bit as a square, and each bit will be either 1 or 0, representing if a piece is on that square or not. And so one bit is able to show basically the position of the pieces on the board, but you cannot specify which type of piece is on that square, and so using just 1s or 0s. And so what I'm doing is I'm making multiple bytes, which all represent a certain position of the board of a certain type of piece. And so I have multiple bit boards, and together they can be used to represent the entire position on the board. The way I'm calculating each moves is by simply shifting bits and adding and subtracting and bits on the byte. And so for example, if a certain piece is on a byte, and I'll show this right there, as you can see, for example, if a knight is on d4, on the square d4, it'll be possibly in this position in the 64-bit. And so in order to move that knight, we can shift the bit by a certain place digit, and that will actually move the piece. And so as you can see, if I shift that bit for the knight on d4 by about 6 or 10 or 15 or 17, that moves the knight up or moves the knight down and moves it in the L shape as according to the rules of the game. And we can do the same thing with the knights and the pawns. And so that's basically how pieces move using this chessboard, using these bitboards. You simply take the square where the piece is on the bitboard, on that specific type of bitboard for that chess piece, and you shift it using simple bit manipulation. And so that's how those pieces move using, for those specific pieces, the knight, the king, and the pawn. The process that I use for rook and knight and queen moves is a little more complicated, because you have to check if the square, because those pieces move in arrays, and you have to check if that ray is not occupied by a certain piece. And to do that, I use a process called magic bit boards, which basically takes a huge database of all the possible moves that that certain type of piece can make from every single square of the board. And so that huge database is then indexed, created by where the piece is on, and a certain magic number. And that creates an index, and using a 2x2, and using that index and the square that the piece is on, it uses those two as indexes to the 2x2 array or database, and that creates the bit board of the generated moves that that piece can possibly make. And so that's basically how these chess pieces moves. Right now I'm currently working on trying to I've worked on the input and output so that the chess program can accept a move, and it'll generate, accept your move, it'll save the move in memory, it'll generate a new move, and you can basically play a game. But right now I'm working on currently debugging the code for the end of game. So very soon it will possibly be finished, but it's not quite yet finished. But you can still play a game, but it's just not really reached the end. And so, as I stated earlier, I'm going to improve on this project by adding a GUI interface where you can actually move the pieces. And then I'm also going to be making some type of artificial intelligence, which will make the computer be able to make an intelligent move. Right now, the moves that the computer makes is completely random. It first generates a random type of piece that it wants to move, and then it chooses which specific piece of that type it wants to move. For example, there are 8 pawns, and it'll have to choose which specific of the 8 pawns to move. And then it'll generate the possible moves that that piece can make and choose one of them. So that's the basic process that the computer will use to make a move. But I'm going to be adding an artificial intelligence later on. And for me, that's one of the major motivations for this chess program, is exploring the topic of artificial intelligence. And it's something that I've kind of been fascinated with sci-fi shows and stuff like that. But yeah, so that's basically how the chess program will work. And yeah, it's something that I'm really excited about.